Okay, so I'm going to answer these questions. 6.2, number 22, asks for you to express x and y in terms of trigonometric ratios of theta. Well, if you just use any trig ratio, trig function, let's just say we use the sine of theta. If I say the sine of theta, that means the opposite leg over the hypotenuse. And if I do that, I get the sine of theta equals x over y. Except now I have two variables. So what you have to do is you have to look at the information you've been given, the x, the y, and the 4, and the degree, the theta position, and say, okay, which trig function can I use so I only have one variable? And in this case, we would use the tangent function of theta because that is the opposite over the adjacent leg. Okay, so now we do a algebra problem. Tangent of theta is equal to x over 4. And so it says express x and y in terms of the trig functions. What that means is solve for x and y. So what we're going to do here is we're going to multiply by 4 on both sides, and then we get our answer. 4 tangent of theta is equal to x. So that's what x is equal to. All right, so now we have to solve for y. And we have y, we're not going to use x again, so we're going to have y and 4. And in these positions, y is the hypotenuse and 4 is the adjacent leg to theta. So what uses the hypotenuse and the adjacent leg? That would be cosine. Cosine of theta is the adjacent leg over the hypotenuse. So we use the cosine of theta equals the adjacent leg 4 over the hypotenuse. Now the problem with this one is that the variable is in your denominator, so we must remove it from the denominator first. And we get y cosine of theta equals 4. And now to solve for y, we divide off the cosine of theta. And then we have our answer, y equals 4 over the cosine of theta. And my guess is in the book is they do not want your trig functions in your denominator. So if we think about this, I'm going to give me a little bit more room here. I'm going to move this up. I'm going to say y equals 4 over 1 times 1 over the cosine of theta. I just separated those. You still get the same thing. But 1 over the cosine of theta is the same thing as one of our identities. So our inverses. So what's the inverse of 1 over cosine of theta? And you will say that is secant of theta. So our answer comes out to be y equals 4 secant of theta. And my guess is that's how it is in the back of the book. And that's how it should be. If that's what we're doing, we're trying to keep everything on the same level, that's what we should do. Okay, now let's go to the next problem. Okay, now we're ready for number 30, and it says without using a calculator. And what that means is these are all values from your unit circle, which that's why we're going to try to make sure we have this. We cannot do the rest of this book without the unit circle, so you should know what the sine of 30 degrees is. If you draw your unit circle and you get 30 degrees, the sine is the y value, which is 1/2. The cosecant is the same thing as the sine. So we have 1 over the sine of 30, or we just take the reciprocal of what the sine of 30 degrees is. Well, again, we just did the sine of 30 degrees, which is 1/2. So the reciprocal of that would be the cosecant, and the reciprocal of 1/2 is 2. So 1/2 times 2 is 1, and that should be the answer. So you have to know all of your reciprocals and all of your unit circle values. Now let's go to number 32. On 32 here, if you want to draw a circle again, your 60 degrees is the tall one here, and we have the long leg and the short leg for x and y. The sine is your long leg, so this is going to be the square root of 3 over 2. That's your long leg, and we're going to square that. And then the cosine is going to be your short leg. Cosine is your x value, which is the short leg, and that's going to be 1/2, and we got to square that. Okay, so again, knowing your values around your unit circle is a must for the whole semester. So if we square this, you square a radical, you're going to get just what's underneath the square root. And you square 2, you get 4. Square 1/2, we get 1/4, and that answer is also 1. Okay, now let's go to number 38. Number 38 says solve this. That means solve every piece of the triangle. So we want this side, we want that side, and we also want the value of that angle. We'll call it theta. So there's 3 things we have to find in this triangle. Again, you don't want to use a trig function that has more than one missing piece, more than one variable. So let's look at what we've been given, and I'll try to highlight this. We have this degree, 75 degrees, and we have that side. So in a right triangle, if we're going with this side, this degree, we have that degree, we have the opposite leg to that degree, and then we can use something else because we have both of those. We have the degree, the opposite leg. Now we can find the hypotenuse, or we could find the adjacent leg. Okay, so let's just, since x is there, x comes before y, we'll do the adjacent leg. So what trig function uses the adjacent leg and the opposite leg? That should be tangent. So the tangent of theta is equal to the opposite over the adjacent. So the tangent of 75 degrees is equal to the opposite leg, 100, over the adjacent leg, x. And now we just solve using algebra. So we multiply by x on both sides because we really do need to get the x out of the denominator. And x tangent of 75 equals 100 then. Now divide off the tangent of 75 degrees. And you get x equals whatever your calculator says, 100 divided by the tangent of 75. Now you're using degrees, so make sure your calculator is in degree mode. And I take 100 divided by the tangent of 75. And that's going to give me 26.8. Okay, so that is number 38. It doesn't say what to round it to, so just go to the tenths always if it doesn't tell you what to do. Now let's go to the next. Oh wait, I'm sorry. We got to solve for y. So let's not use 26.8 for x. Let's not use the stuff that we find until we have to. Let's use what we've been given. So we go back to 75 degrees. And again, we have the 100, which is the opposite leg to 75. And now we want y, which is the hypotenuse. So what uses the opposite leg and hypotenuse? That would be the sine function. So the sine of theta is equal to the opposite over the hypotenuse. And now let's fill everything in. The sine of 75 is equal to the opposite leg, 100, over the hypotenuse, y. So now we multiply by y to get it out of the denominator. And we have y, sine of 75, equals 100. And we divide off the sine of 75 at this point. And again, just use your calculator, and you will get y equals 100 divided by the sine of 75. And I get 103.5. So those are not degrees. Those are the lengths of those legs. There's one other thing in this triangle we haven't solved for, and that's theta. Well, there's 180 degrees in a triangle. So if we subtract the 90 degrees that we were given, and we subtract the 75, and that leaves theta to be 15 degrees. And so that would be the actual answer for number 38. Now, 42. 42 is another solving problem. So again, you should know what, let's just do the easy one. Let's do the degree since we did that last in the last problem. So we have pi over 6 is that degree. What is pi over 6 as a degree? And that is 180 divided by 6, which is 30. So technically speaking, this is 30 degrees. And that makes this 60 degrees. All right, so since we have not been given the 60, I'm going to use the 30 degree position to start with. You could use the 60 if you wanted to, but I try to make sure we use all the stuff that's given in the problem as we're solving things. Try not to use anything that you've rounded. Okay, now 60 is not rounded, so it'd be okay to use that one if you wanted to. But for the sake of keeping it consistent, I'm going to use 30-degree position. So what does that mean? I have 30 degrees, and I have the adjacent leg of 72.3. I need to find that value and that value. Okay? So I've already found the 1 degree. I just need x and y at this point. So from 30 degrees, if I want to find x, that's the opposite leg, and I've been given the adjacent leg. So that's tangent of 30 is the opposite leg over the adjacent leg, 72.3. And now we just solve by multiplying by 72.3 on both sides. And then we'll get x all by itself. So 72.3 times the tangent of 30. And that's 41.7. And now we look at y. Y is the hypotenuse position. So what uses the adjacent leg and the hypotenuse? That would be the cosine of 30 degrees is equal to the adjacent leg over the hypotenuse. Now, the hypotenuse there are variables in the denominator. We must get that out of the denominator by multiplying by it. And you could, instead of using calculator, you should know what the cosine of 30 degrees is. And that's going to be the square root of 3 over 2. But since we're using decimals, we can go ahead and just use our calculator for that. We're going to divide off the cosine of 30. And if you need to ever pause these recordings, do so you can try to work it out ahead of time. And therefore, we get 72.3 divided by the cosine of 30, and that is 83.5. And we also found, we'll just call that theta. Theta was 60 degrees. So there is our answer for number 42. All right, we'll see everybody tomorrow. Maybe, hopefully. Probably a 2-hour delay, but that's all right. Send me any questions you have, or just hold on to them. We'll spend tomorrow answering them. If it is a full day, we are supposed to have that test, but since it's a Friday, I got to figure out what we're going to do. So plan on having the Chapter 5 test retake tomorrow, unless it's a 2-hour delay. Thanks.